Major support for Do the Math has been provided by Chevron, the Kern County Superintendent of Schools, Edison International, California Resources Corporation, Kern Schools Federal Credit Union, Panama Buena Vista Union School District, Bakersfield City School District, and the Kern High School District, with additional production assistance provided by these supporters of education in Kern County and throughout the state of California.
Well, good afternoon and welcome to Do the Math. I'm Michael.
And I'm Devin. Hey, thank you so much for being here today. A wonderful Wednesday. We've got a lot to cover. We've got a great guest for you coming in to help us out. And most importantly, we've got time with your homework problems and your phone calls. So go ahead and give us a call here in Bakersfield at 636-4357. If you're calling us from the San Luis Obispo area, that call is toll free at 1-866-636-6284. You can email us questions during the course of the week, and we can respond to them right here on the show at dothemath@kern.org. And you can watch our streaming feed when we're live and check out past broadcasts at dothemathonline.net. Hey, if you're on social media too, check out all the socials. We're on Facebook, we're on Instagram, Twitter, and YouTube. Connect with us on the show. We're here for you.
All right, as a matter of fact, there was an email problem presented. It wasn't an exact problem, but it has to do with dividing with base 10 blocks. So we might address that a little bit later on, and maybe we'll put our guest to work with a little bit of something, because the student that emailed is in 5th grade, and our guest is in 5th grade. So we'll see if we can come up with a little problem with her.
Make that link.
Anyway, we will be going out and about. Scott is out at Meadows Field right now taking a look at some planes, so we'll visit with those guys in a little bit. But before we get to any of that, let's first take a look at today's Math in the News. Now, today's Math in the News astounded me when I saw the number that was associated with this thing.
That takes a lot.
All right.
Okay.
So let's first of all take a look at the picture on the
Oh, the
smart
boy.
board here right
How
now.
are you, this guy? He's professional.
So, a lovely dog there. And what do you notice about the dog?
Could use an iron. A lot of wrinkles.
Right, a lot of wrinkles in that iron, in that dog.
I would recommend that, ladies and gentlemen. Please don't iron your dogs.
Yeah. He's got his tie.
Right.
A fashionable beast right there.
Very well kept.
All
Is
right.
that a Windsor, half Windsor?
Well, that's kind of what we're going to talk about here.
Ooh.
All right.
Okay.
Now, one of the things, where do you think fashion is the top, or originated, or
Right
is
here in this
known-
studio. I get what you're saying. That's right. This is the place, ladies and
Yeah,
gentlemen.
this is the place. So where would you guess fashion,
I mean, you think of your
a
top
fashion
spots.
capital of the world?
Well, you can think of Paris. You can think of New York, London. I think Los Angeles.
Now,
can
if you had to
certainly
put,
go there.
if you had to say one,
Let's go Paris.
all right, so that's good. You went with France, all right, because this is going to go back a long time ago. So for fashion, there are a lot of things that are impractical. And when we were getting ready to come on this afternoon, Janet was like, hey, whoever invented high heels for women needs to be taken care of also. But another one is the necktie that a lot of people find impractical. And that is all blamed on a king and France, all right?
Understand.
So when we think of fashion capitals of the world, Paris is on the top of the list. New York, I would say, is a close second, but it originated in Paris. So King Louis XIV was the nation's longest reigning king, all right? During his time, he came out with Louis's New Deal. Furniture, textile, clothing, and jewelry industries were established, not only providing jobs for their subjects, but made France the world's leader in taste and technology. As a side effect of the boom, Louis XIV became the king of fashion. Whatever he wore, others wore and copied him. Okay. Now, he was young when he took over. He was 4 years old, which is one of the reasons why he reigned for so long, right? Under Louis the 13th, his father.
Yes.
The French military decided to bolster its fighting force, hiring mercenaries from Croatia. The uniforms, and we'll take a look right here, that the mercenaries had,
Oh boy.
had a cloak, all right? Kept them warm, and they would tie one end of it around, and they would put it in a ornate bow, okay? So you can see this is how they started. These are some of the different ornate bows that you could tie.
Some of the knots that they would use to keep that cape secure.
Right. So what happened later on was the uniforms became part of the army.
Right. So they,
Then what they wanted to do was they wanted to get rid of the cloak. So therefore they kept the bow. So the tie was born with that. Once again, as everybody sees the king wearing them, everybody else is going to wear them.
nobody wanted to tell the king, hey, you probably don't need that thing since we lost
There are a
the
lot
king.
of
You know what, king?
stories
Go for
like
it.
that too.
Yeah.
Anyway, so here we go. This is what I found. This is what brought me to this whole thing with the ties. So scientists are constantly striving to do good for the common man. 2 physicists in Britain have come to the aid of the well-dressed man. Seeking a marriage of science and beauty, Fink and Mao from Cambridge applied the rigors of mathematics to that most basic of fashion statements, the necktie knot. They came up with 6 ways of tying a tie, okay? We thought there were probably unknown knots that have yet to be stumbled upon. So the difficult part was converting aesthetic criteria into mathematical constraints. In their work, a map of a walk corresponds to the movements of the wide end of the tie. Using an upper limit of 9 moves, they determined there were 85 different knots possible. So I was like, all right, so this thing went from 6 to now you've got 85 different knots. But let's not stop there. So another guy, a mathematician in Stockholm, led a small team on a quest to see how many knots are possible. They came up with over 170,000, okay, to tie the knot. So what's the discrepancy? It comes down to what counts in tie tying. Take, for example, the conventional standard. The knot must be covered by the cloth of the tie. Now, there was a film, The Matrix Reloaded. The character sports a tie where the knot is exposed and where the big end of the tie goes behind the small end. And what they did is they did all of this, and they came up with, all right, let's do some more calculations, and this is how we have over 170,000 different ways to tie a tie. I, myself, still only use 1.
Let's go with 3 to be an expert.
I mean, the one that I grew up with that my father showed me, that was the one that I did. It's the one that I remember. Easy enough to do.
The bolo tie.
And then
There it is.
that's it. And that is today's Math in the News. Fashion accessories, and you know what, never knew that, but when I saw that article about the number of ways to tie a tie, it was like, all right, we've got to delve into
Beyond
this a
that
little bit
too,
deeper right here.
Beyond that too, it's, if you go do a deep dive on YouTube, if you're ever looking to learn how to tie a bow tie, there are 36 different videos that have 1 million views each.
Oh, there you go.
There's your
a lot of
business
different ways to
plan
do your
right
bow
there.
ties.
That's right.
In studio with us right now, we have Claire. How are you today?
Good.
Why don't you let everybody know where you go to school and what grade you're in?
I'm in 5th grade and I go to Stockdale Elementary School.
Now, you're not the least bit nervous, are you?
No.
Why is that?
Well, I've been on Do the Math before and
That's right.
last year was kind of nerve-wracking, but it's really good to be back here and because last year was really fun and
Well, good. I'm glad that it was fun for you last year. You were a little bit nervous being in 4th grade. Now you're in 5th grade, you know kind of how it works and everything's pretty cool now, right?
Yep.
So before we get started, why don't you tell me what is the best thing about 5th grade? Because you've been in 5th grade now for a couple of months and you're going to get your report card, I think, coming up soon, right?
Yeah.
Yeah. Is that going to be good?
Should be.
I'm sure it is, right? Anyway, what's the best thing about 5th grade?
The best thing about 5th grade so far would probably be long division for me because I really love long division.
So you like long
She
division?
says that the best part of 5th
Yeah,
grade.
the best part. All right, well, you know what? If that's the best
Wow.
part, to the board, young lady.
I commend
Let's
you.
go.
Wow.
All right, so we don't have any of your math homework problems here. And we're not really quite sure how this is going to work out because we're just going to come up with some numbers right now, right?
Okay.
So go ahead and draw your division house. I think that's what you guys call it, right? Your division house. A lot of people have different names for it.
Color bracket. Oh, she's
Oh,
throwing
you're
some numbers
going
out
ahead
right
and putting
there.
numbers up there.
Okay.
All right. What do you want to put on the outside?
So we're
Excellent.
going
All right.
4-digit divided by 2-digit, okay?
So explain to Devin how you're going to solve this problem.
Well, we are going to put, so 42 can't go into 6, but it can go into 69. So we got to put the 42, oops,
Okay,
42 right here, and we put 1, oh my gosh, it won't let me.
you got it.
So we can't, well, we can, but, so we would put this 27, right? So we would bring down the 2, and we know that equals 272. So 42 can go into 272, but we need to multiply to see to what number is the closest to 272. So 42 times what would equal closest to 272, and the closest without going over. So we
Now, this is the point where a lot of kids really get caught up because they feel like they have to memorize their 42 times tables. And so what are some of the strategies that help you make sense of values like this when we deal with 2-digit into 3-digit where maybe the numbers are not close enough to be familiar quite yet? How would you think about this?
Yeah, estimate a little bit.
I think estimation is always a great way to go. So instead of thinking of this as 42 and 272, maybe we work with friendlier numbers. So what could we use as a friendlier alternative to 42?
40.
Okay, and then what about 272? What could we try?
270.
Okay, so how many times could we get 40 into 270?
About 6 times.
Yeah, because if we do 6 of these, that's going to get us to, let's say,
Around
240?
Yeah.
So if we can get 40 into 270 about 6 times, maybe we can get 42 into 272 about 6 times. So let's try that and see where that gets us.
So.
We have to start multiplying now, right? So
Okay.
we're basically doing how many of this 272 can be taken up by 6 42. So we can do 42 times 6.
I can
Right?
do that. 1, 12, 24, 25, 252.
Okay, so we know that 42 times 6 is 252. How much are we going to have remaining once we subtract this?
10. I went 20.
20, okay?
20.
So we end up in this place, 42 with 20 remaining. Is there still another 2 we have to bring down?
Yes.
Let's go ahead and do that here because now we're including this ones place. So let's think about this estimation strategy that we just used for 272. Could we apply the same idea and logic to 200 too?
Well, yes, but we can't use 6.
No, because that would be too high. Could we use 5?
Maybe?
It's worth trying, right?
Yeah.
So let's try with 5.
So,
Here's an easy way to do that. Take your 252 that you had and subtract 42 from it.
Because we're just taking 142 away to make this 5, right?
okay. 0, 1, 2,
So 210. Now, this poses a problem for us since we can't really subtract with this, huh? But that's actually good information. That doesn't mean we're off track. In fact, we're closer than ever. So if 5 is still too many, what do you think our next attempt should be?
4.
So let's change this up here. You erase that, I'll erase this.
Okay.
What's gonna work? Teamwork. So, you know what I'm talking about. Thank you, Wonder Pets. Now let's try with 4 instead.
Okay. So, 210 minus 40.
Again, continuing that strategy of repeated subtraction as we go lower with our multiples of 42.
All right, you guys have a moment to continue with this, and it's going to come out to be a big decimal, so we're going to round it to the nearest tenth.
And there's actually an alternative way to look at those remainders as well once we figure this out here. So 168, we can subtract 168. I'll take care of this piece here. That's fine. So we'll have 12, and this will be 1, so 34. Now that means that we have 34 out of the 42 left for a last group. Why don't we just make that a fraction? 34 40-seconds. So 6,922 divided by 42 gets us 164 and 34 40-seconds. That way we don't have to round a decimal. This is precise and exact because there's 34 of the last set of 42 remaining.
And is there anything you can do to that? Because I'll give you about 20 seconds. Is there any way you can simplify that fraction? So this might be something new for you, right? Because you haven't done a lot with fractions yet. Can you think of a number that goes into 34 and 42? What will go into any even number?
4.
Will go into, right? What about 2?
Yes.
All right, so divide each of those by 2.
Divided by 2. Looks like 3. Okay. So that would be 2. That would be. Wait.
Yeah, you can set it up a different way. I think the way you got it set up is going to
I
mess
didn't
you up
see
a
where
little
that was
bit.
going because I've never
So here's
seen
what
it.
we'll do. I'll do the top one. 34 divided by 2 is 17. And now you do the bottom one. 42 divided by 2. So what's 2 divided by 2?
1.
Right, so put a 1 underneath it. Now what's 4 divided by 2?
2.
So put a 2 next to it. So 42 divided by 2 is
21.
21. All right, so you can get it even simplified to 17 over 21. And we'll leave it at that right now, and that is your problem you came up with. Nicely done. All right, time to go out and about, going out to Meadows Field and checking out the next stage after Cessnas with Scott and Ryan.
Hey, thanks, Mike. We're here at the Bakersfield Airport, live at the Bakersfield Jet Center. And this is definitely not the quietest place in Bakersfield. But we're here anyway, and we're here today with Ryan Crowell from the Bakersfield Jet Center. Ryan, thanks for your time, man.
Thank you.
Glad
Thanks
you
for
could be
having
here.
me. Yeah, glad
It
to
was
be
nice
here.
and quiet for us quite a while, but of course,
know.
this is a busy place.
It's an airport. So
It's an airport.
We have airplanes.
That's part of the deal. That's it. So can you tell us a little bit about what we're standing in front of right here?
Well, we're here at the Bakersfield Jet Center. We are a corporate aircraft service company, really.
Right.
And this is one of the airplanes that we use to transport people around for business and corporate meetings, that kind of thing.
Right.
So this is a Beechcraft Baron. It's a 58 model Baron.
Okay.
And this airplane's been in production more or less for about the last 40 years.
Okay.
Very popular airplane. It's a piston airplane, so that means it has a reciprocating engine, 6 cylinders per side, flat arrangement similar to an old Volkswagen.
Okay. Gotcha.
So we have 2 engines here. We'll kind of walk around and
Sure.
I'll show you a little bit about the airplane.
All
So
right.
we have 2 engines. Each one's 300 horsepower apiece.
All right.
So a total of 600 horsepower for this airplane. Kind of cool. It's certified to fly through all kinds of weather and ice and really anything you need to. This is kind of a regional airplane. Take
Right.
you around California,
Right.
over maybe Las Vegas or San Diego. It'll do all kinds of stuff like that. Carry up to 6 people, so pilot plus 5 others.
Okay.
So we'll take you around here and we'll show you inside.
Good deal. Do you need 2 pilots to fly this plane? I mean, a lot
No,
of planes
just-
that people are on have 2 pilots, right?
Yeah,
Like a
no.
pilot and co-pilot.
Just one for this airplane.
Okay.
Yeah, single pilot. We've got the back here, so nice and comfortable for up to 4 people in the back.
And everybody gets to sit facing each other. So
Yeah.
They can have a nice little conversation while they're
Yeah.
going to their destination.
Absolutely. And we'll jump inside and I'll show you what it looks like from the cockpit.
All right. Good deal. All right. So it has room for 2, right?
Yeah, room for 2.
Up here. but only one person necessary to actually fly it.
Right. Only
Okay.
one necessary. We've got a glass cockpit, we call it. So it's just computer screens that replace a lot of the old round dials that you used to see in airplanes.
Oh, right,
Technology's gotten a lot better. We do have some backup instruments over here that we use for.
That are not digital. So in
correct.
case your digital stuff goes down, you can have some readings over here
Yeah.
that are still going to work. And we
Yeah.
talked a little bit earlier too, and I want to make another mention of it, the fact that you really, as a pilot, have to do some mental math, right? Because
Absolutely.
this stuff is going to do all kinds of calculations for you, but at the same time, this is not always going to be 100%. We know that computers don't always function like we want them to, and if you can do some math in your head,
Yeah.
then at least you'll have an idea of what this should say, and certainly be able to make some calculations without having to rely on that completely.
Right, and the computer has a lot of backups to it,
Okay.
but there's some things that are just faster. We could program a computer to figure out how fast we need to descend.
Right.
If we have, say 10 minutes to the destination, we have to lose 10,000 feet, that's 1,000 feet a minute.
Yeah.
That's real quick.
Sure.
If you can do that in your head, it just makes life a little easier, and it's
Right.
quicker than programming a computer to tell you how to do it.
Right.
But this,
So how long have you been doing this? How long have you personally been a pilot?
I've been a pilot for about 22 years.
Okay.
I've been here at Bakersfield Jet Center and Lloyd's Aviation for about 13 years.
All right. And how long do you think it took you, if you can remember back, when you first started as a pilot, to kind of get some of this stuff down, to feel comfortable doing that mental math in your head? I mean, there's a lot of training that goes along with being a pilot, right?
There is, and you start out in small airplanes,
Right.
and about the time you get that figured out, you jump up to a bigger one,
Right.
and then you kind of start all over. It's like flexing a muscle. You got to get your head to build up to the faster airplanes. You got to
Right.
make decisions faster. You got to make calculations faster.
Right.
You just have to mentally keep up with the faster airplane and the more complex airplane. We have 2 engines here,
Okay.
so there's twice as many things to pay attention to.
Right.
We've got 2 gauges for everything. We've got 2 levers for everything.
Right.
So just more to pay attention to. And this is an airplane that's moving about 170 knots.
Okay. So now we're getting into some terms in aviation that maybe we don't use as often or ever actually in a car. Tell us about a knot. What is a knot?
So a knot is a nautical mile per hour. So
Okay.
we think miles per hour in our car.
Right.
That's actually a statute mile, 5,280 feet.
Right.
A nautical mile comes from nautical, or the sea,
Okay.
is 6,013 feet. So it's 15%. So if you take knots at 170 and add 15%, you get miles per hour. It's 15%
Okay.
longer.
All right. Gotcha.
So this is about 170 knots. An airplane that you would train in would be more around 90 knots.
Okay.
So you're going 80
Gotcha.
knots faster. Everything's happening that much faster to get in,
Right.
and you've got 2 of everything.
Right.
So that's
Lots
why.
of things to keep in your mind. No
yeah,
doubt.
yeah,
Huh.
and it's fun. It's challenging because
Yeah.
as you grow in the airplanes and as you get faster and faster, you master something new,
Right.
and then you go, okay, where's the next one?
Where's the next one? That's
Yeah.
right. And of course, the next step is going to require some new and different training as well, because you have a new
Right.
machine to master and you're going faster.
Right.
Lots of different variables. Well, we're really excited to know about this process, but we're also excited to know about what other things you have around here. So when we come back, then we're going to go ahead and get to another aircraft. But man, right now, we are really interested in what's going on here and the information that we're being given. But we know there's some math to do back in the studio as well. So we're going to head back to the studio, Mike, and we'll be back in a little while with some more information about the airplanes out here at the Bakersfield Jet Center.
All right, thanks for that, Scott. We'll hook up with Scott and Ryan in just a little bit. And fascinating, the world of aviation, especially having gone through it with my son, learning to be a pilot and stuff, just the amount of math that is involved and the amount of math that you need to know at a moment's notice.
And the amount of math that's accessible to the students that are going through school right now. A lot of it is the same type of calculations. I really hope that pilot gives Scott his wings. He's been asking for those for a long time.
He's going to have to get in something besides a simulator also. 636-4357 is the phone number. We do have phone tutors available most Tuesdays and Wednesdays throughout the regular school year. And right now we're going to go to the phones. And Ruby, how are you this afternoon? I think we're going to get Ruby on the phone in just a moment. I know that Ruby has phoned in a couple of times. She's a 6th grade student at heart and has called in. So Ruby, what's going on today?
Just a simple math problem.
All right, let's hear it when you're ready.
Okay. It's 7n minus 4 parentheses 2 minus 3n parentheses equals negative 27.
And I think, Devin, just
That's
change
right.
the x to an n.
Yeah, this is the same variable here.
Right.
That was my miss here. Okay, so we've got n showing up a couple of times. We've got some parentheses, and we've got negative values. So there's a lot happening here. So we can kind of anticipate what we can expect to do before we even start. I think that's something that a lot of the times we overlook before we really start, is taking a step back, looking at what's there, and predicting what we're going to need to keep in mind. So the fact that there's distributive property means that we're going to be multiplying in eventually. The fact that there are a couple of n's means we're going to be combining like terms at some point. And the fact that there's a negative on one side means we're probably going to have to be dealing with integers. So there's a lot to consider. However, that's where our order of operations can always come in handy. So, Ruby, where would you like to start with our work here?
I would like to start by taking down the 7n.
Yeah,
Not
let's go
completely
ahead.
getting rid of it, but putting it off to the side.
Yeah, let's move that off. Now, we can do something interesting with the 7n. Do you want to kind of move it off to the side and isolate it, or do you want to bring it over with the negative 27, perhaps?
I don't want to completely get rid of it, but just to put it off to the side.
I'll just put it off to the side. What Ruby
To
says,
put into our
we
first
do
line.
here. There, right there. There's our 7n. Okay, we'll bring that back a little bit later. So now we have our negative 4 with our parentheses. What's our next step?
Our next step is to do negative 4 times a positive 2.
Okay, so we're going to distribute that negative 4. So we're no longer seeing that as a minus. Now it's a negative. We're going to distribute that into the parentheses, starting with our 2. So when we multiply negative 4 and positive 2,
We get negative 8.
negative 8. Okay. Following that, we're going to have to multiply negative 4 by something else too. Okay?
We would do negative 4 times the negative 3n.
Okay, so a few things are going to be happening there. We're multiplying a constant with a variable, and we have two negative signs. What does that get us?
Positive 12n.
Positive 12n. Multiply two negatives together, you make them a positive. Multiply the values together, and then bring in that n. So we now have negative 8 plus 12n equals negative 27.
Yep.
Sure do. So what's our next step? Where would you like to go from here?
Our next step is to re-add back to the equation that is positive 7n.
Hey, 7n, come back home. Glad to see you again. So what can we do with that 7n now?
Now we could combine it with the positive 12n.
Let's bring that in. And it looks like a pretty simple combination. So we'll go ahead and we will bring that n back here with that 7n. Looks like we can add them together pretty easily. So when we combine 12n and 7n,
We get 19n.
19n. So we now have, I'm going to go ahead and move that over here. We have 19n paired up with our 8, our negative 8. So what's our next step?
Our next step is to get rid of the negative 8 by adding 8.
So we're going to add 8. And we're going to do that not just on the left side of the equation. We're going to do that to the right side as well.
Yep.
So we can go ahead and take care of these values on the left. And now we have negative 27 plus 8 on the right side of our equation. So what do we do with negative 27 plus 8?
We get a negative 19.
Oh, that's very convenient for us. That's very convenient. So now we have 19n equaling negative 19. Looks like there's one step to go here until we figure out what the value of n is, Ruby.
Yep. Our one step is to divide.
Let's go ahead and divide. What are we going to be dividing by here?
19.
Let's divide both sides by 19. I'm not usually a big fan of dividing by 19, but when I'm dividing 19 by 19 or negative 19, it's all right with me because when we do that, we end up with n equaling what?
Negative 1.
N equals negative 1. We'll plug that back into our original problem and see that both sides of the equation end up the same. Nicely done, Ruby. Great job.
There you go. Thanks for that call. And Ruby, if you're still online with us, congratulations, because you now have yourself a free meal courtesy of our friends at Grill and Burger. So there you go.
Get the fire extinguisher.
Congratulations on that. Hey, listen, if they're making food like that taste good, you deal with a little smoke right there. young
I
man.
guess I have to.
All right, you know what? We're going to have Claire do a little bit more work, but we'll do that right after this.
I'll be okay.
Today we're at Piute Mountain School, home of the Wranglers, and we're here to... And we're back at Piute Mountain School, and we've got the 6th, 7th, and 8th graders. We put forth the challenge to them to roll some dice and see what number came up the most out of 10 rolls, and then see if there's a way to determine if 7 truly is a lucky number with probability. So let's go ahead and take a look and see what's going on so far. Does anybody have their 10 rolls complete?
Yes.
Almost? Anybody at this table have their 10 rolls complete? Yes. Okay, so out of your 10 rolls, was there a number that came up the most often?
4.
11.
So you have 11 as the most, all right?
5 and 7.
All came out equally the same?
I have 2.
You have 2 of each?
Yeah.
Okay, so 3, 5, and 7, 11.
3. Not 3, 4. 4 threes.
10, 6, and 11.
They all came up twice? All right. So did anybody over here get a number occurring more often than any other number?
They all came out 2.
You got 5 and 6?
I got 3 pairs of,
So you got a lot of 5s and a lot of 6s?
3, yeah.
Okay. Anything come out the most?
They all came out double except for 10.
Okay, so you got a lot of doubles,
Yes.
except for the number 10 came out once. Did you get any number that came out more than once? What number? 4? All right. So, almost wrapped up with your 10 rolls? All right. What number came up the most?
7.
7. 7.
9.
9. And what number did you get come up the most?
10.
4?
Just 10.
That was 4 that came.
Oh, more 4s than anything else. There we go.
Everything's equal. The highest number that I got was 8.
Everything came out once?
What came out most is 7.
Everything that
You have 7 the most? Okay, so 3 of you girls had 7 come out the most. That's definitely a lucky table right here today. All right. So let's take a look and see if we roll 2 dice, and you guys are going to help me out with this, all of the different combinations we could come up with, all right? So here's what we're going to do. If we have a 1 and a 1, we're going to get a 2. If I roll a 1, what else could I roll with that? A 1 and a 2. Then I could roll a 1 and a 3. A 1 and a 4. A 1 and a 5. A 1 and a 6. Anything else?
7. No.
That's it. Okay. So I've got 4, 5, 6, and 7. Okay. So if it's easier for you, if you need to write this down on your paper, you can do that also. So what I want you to do is figure out. So now we're going to do the 2. Can I do a 2 and a 1, or is it already done? Right.
Yeah, 2 and
Okay. Well, let's say we're going to go a 2 and a 1. Okay. So there's a 3. We can do a 2 and a 2, right? So what I want you to do is keep on going. I want you to come up with all of the different combinations. Go. Just do it right in order like I'm doing. All right, here we are. We've got the kids rolling the dice, seeing if there is a number that comes up more often than not, maybe a lucky number for some people, because a lot of times when you were rolling just a 10, it seemed as though 7 came up a lot with some kids. Now, who's got all of the different combinations? And did
6
you?
came up the most because all of them correspond with the 6.
Okay, so we're going to see. So your total was 6 that came out the most often?
Yeah.
As far as when you add up all of the numbers? So let's take a look up here. Here are the different ways we can get 7. All right? 1 and 6, 2 and 5, 3 and 4, 4 and 3, 5 and 2, 6 and 1. Are there other ways to get 7 besides the ways that are on the board right now? Are there any other ways that we can get 7? So we have 1, 2, 3, 4, 5, 6 different ways right now to get 7. All right, let's try the next number. Oh, do you see one? You could multiply? Well, we're not going to multiply. We're just going to add. All right? So somebody said 6 came up a lot. What are the different ways we could get 6? We could do 1 and 5, right? 2 and 4, 3 and 3. Well, if we did them the opposite way, right? Okay, but here, how many different ways are there? 5, right? Now let's go on the other side of 7. Let's try 8. Okay, so let's try 8. We can't do 1 plus anything, can we? No. So we can do 2 and 6, 3 and 5, 4 and 4, and then we'll go the other way, right? 5 and 3 and 6 and 2. But because it has more combinations, ways to come up, that's why sometimes people think 7 is their lucky number. And that, just a little bit on probability, with the 6th, 7th, and 8th grade students at Piute Mountain School. Well, thanks to Kathleen Hansen again, the principal, and all of the students at Piute Mountain School. Certainly a memorable trip, one that I shall not forget for quite some time. 636-4357 is the phone number. We do have phone tutors available until 5:30. And speaking of memorable trips, a lot of times you can take one when you're on an airplane. Let's head on back out and visit with Scott and Ryan.
Hey, thanks, Mike. We're back here live at the Bakersfield Jet Center with Ryan Crowell. And we just got a chance to see some amazing pieces of machinery where the plane was a little smaller. We're next to a little bit bigger plane. But before we get to exactly what's going on with this machine here, Ryan, I want you to explain a little bit about the general idea of aviation. Can you tell us a little bit, since we're standing by this wing here, can you tell us a little bit about lift and why an airplane flies? Because it's a big piece of metal. How do we get that thing off the ground?
Sure. Well, we've learned a lot over the years from birds and observation.
Right.
And we owe a lot to Mr. Bernoulli and his principle.
Right.
That's really how an airplane flies. So the way a wing is shaped, you'll notice that it's curved on the top and that it's relatively flat on the bottom.
Right.
What that does is it creates, as the air flows, it creates a Venturi effect over the top. So the airflow actually speeds up here and creates a low pressure. So you get a low pressure right about here over the wing and a relative high pressure under the wing. Well, we know that air always goes from high to low.
Right.
And we create a high pressure to low pressure difference, then that creates lift in that direction. And in our case, it's vertical.
Right.
And we use that to then obviously lift the airplane, but we also use the same principle to control the airplane.
Okay.
So, for example, we use the tail to create and destroy lift so we can tilt the airplane or pitch the airplane.
Okay.
We can pitch it up and down using the elevator in the back. It's just a small wing. We call them airfoils. If they happen to be here, it's a wing. If it's there, it's an elevator.
Okay.
And then we can manipulate the wing out on the wing tip there with an aileron, and we can increase lift on one side and decrease it on another and cause the airplane to bank.
That's how we can turn.
And then really what turns the airplane is when we take that lift that's pointed straight up, we take that vector and we rotate it. So now that it's pointed this way, we have a vertical component and we have a horizontal component of lift. And it's that horizontal component of lift that turns the airplane.
Oh, wow. Good deal. And the faster you go, the more lift you get, is that correct?
Yeah, that is correct. The faster we go, the faster we can get the air to flow over the top of this wing.
Right.
The greater pressure difference we can create, and therefore the more lift we can use.
Gotcha. So we go from a smaller machine to a bigger machine, and we get to go faster. Now, we talked a little bit about all these amazing things that make this piece of metal go in the air. What are some problems that you as a pilot have to worry about in the air? Like, we've heard a little bit about ice, right? You can get ice on a wing?
Yeah, sure. Well, we're flying through the air, so there's clouds and rain and ice and hail.
Right.
So we have to pay attention to that.
Right.
When we get this nice smooth airflow over the wing, it works great. But when you get ice on it, it disrupts the airflow, and now we have a problem.
Right.
So what we do on this particular airplane is we heat this leading edge. That's why it's not painted. So we heat this leading edge all the way down, and it keeps the ice off the wing.
Right.
So we also do the same thing if you look at the engine inlet.
Oh, okay.
The last thing you want is ice building up on the front of that, and then it breaks loose and right through the engine.
Right.
So
that would be a problem.
Yeah. So we heat the engine lip that we call it.
Yeah.
And that keeps the ice from forming and going into the engine.
Gotcha. So we want to avoid ice, but it's okay to fly through clouds.
It is.
Right, but what's the danger there if we fly through a cloud? We got to worry about something else, right?
Well, just in the clouds is really just like driving through fog.
Okay.
So you can't see where you're going.
Right.
But it's really no different than maybe standing in the steam in your shower or driving through the fog of Bakersfield. You just can't see. So now you have to create artificial horizons or instruments that tell you where you are and how the airplane is oriented so that you don't get disoriented.
Gotcha. And then static electricity, is that where we get that from as well?
Yeah, we have static electricity when we fly through clouds because it creates friction over the wing.
Okay.
And so we have on the back of this wing, you can see there's a red one on the end.
Right.
The other two, those are called static wicks, and they discharge static electricity off of the airplane.
Okay, gotcha. That totally makes sense. All right, so we have some things that we're interested in knowing about how we can stay as safe as possible.
Right.
Now, we're going to get off the ground because of lift, and we're going to be able to fly through the air as fast as we can to get even more lift, but then we got to come back to the ground, right?
Right.
So I know that one of my questions has always been, these tires on this machine have to be different than the tires on my car.
Sure.
Can you tell us a little bit about the tires and the landing gear here?
So the tire here on this particular airplane it's a thicker, it's a 10 ply tire.
Okay.
And that tire is rated to 165 miles an hour because that airplane is landing at about 100 to 115 miles an hour, and that tire has to go from zero, where it's stopped in the air, to as soon as it touches down, it has to spin up to 115 miles an hour right now.
Sure.
So it's got to be a beefy tire, it's got to be a sturdy tire. But then once we stop, we use our brakes, which create heat.
Yeah.
That thing has 200 psi in it, pounds per square inch. You get it too hot and it would blow up. So we actually have fuse plugs in there that if it does get too hot, they melt, let the air out, and now it's not a safety hazard.
Gotcha. And this all takes a lot of engineering, right? A lot of engineering.
Yeah.
And hopefully not by making too many mistakes, but that's one way to learn. But the other way we learn, of course, is we can do some math ahead of time and be able to figure out all these problems beforehand and avoid them, right?
Yeah.
Wow, okay, so we've gotten off the ground, we've gotten back to the ground safely. We want to know a little bit more when we come back in the next section about what the difference is between the aircraft that we saw earlier and this one here.
Sure.
That one has a propeller, this one doesn't. I've always wondered what's the difference? Why would we go from an airplane that has a propeller to one that doesn't? So when we come back, we're going to learn a little bit about that and a little bit more about the safety and mathematical parts of aviation. But at the moment, I know there's some more math to do back in the studio. We'll get it back to you, Mike.
All right, thanks for that, Scott. Always more math to do, and we've got the perfect person to do it. We've got Claire in studio today. Now, you're in 5th grade, and you said that you're working on long division. So you know how to add, subtract, multiply, and divide. So we're going to go all the way back to adding. All right?
Okay.
But now we're going to add fractions. And you know a little bit about that, right?
Yeah.
All right, head on over to the board. So let's, you go ahead and make a fraction. Both numbers, numerator and denominator, will be single digits. So they have to be between 1 and 9.
Okay.
So go ahead and make one up.
She goes with 5 ninths.
5 over 9? All right, so add to that. So you're going to add, let's go 7 ninths. So now if you would go ahead and do that one for us and explain what you're doing.
So we wouldn't add the two denominators because they're the same digits. We would mostly add the 5 and 7 to equal 12 ninths. But this right here is an improper fraction. So we would have to equal this into something different. like there can be 1 3/9 because 3 plus 9 equals 12, and only 9 can go into 12 one time. So we would put 1 3/9, not 2, 1 3/9.
Okay, so you've got 3/9. Now take a look at the 3 over 9. Can you simplify that? So is there anything that will go into 3 and 9?
Yes.
What?
3.
All right, so go ahead and simplify that.
It's not like me right now.
Oh, I don't think it's a matter of liking you. I think it's just a matter of being told what to do at just the right time.
That would equal 1, and this would equal 3.
And then we want to make sure we include this 1 in there as well. So we know that 1 3/9 is equivalent to 1 1/3, because 3/9 and 1/3 are equivalent fractions. Okay. Wonderful. And I like how you decided to add those numerators together, because if we think about these in like a circle, like if a circle is broken into 9 pieces, and we're adding 5 of those 9th pieces and 7 of those 9th pieces, like they don't automatically become smaller. Like those pieces stay the same size, we're just adding quantities of those together. So I always like to think of common denominators as words, like because they're a common unit. Like when we add inches and inches together, we don't all of a sudden have double inches. So by keeping the unit the same, we're able to make sense of adding together, because we're adding 2 of the same kind of thing. So that's how you got 5/9 and 7/9 to equal 12/9, which we then converted to a mixed number.
Mm-hmm.
All right, so since you had the same denominator, let's change it up a little bit now, shall we?
Okay.
All right, so Claire, do the same thing. You'll come up with another fraction.
Okay, so let's do...
Single digits still?
Single.
Okay. Don't put 0 in the denominator. You will send a lot of our math viewers off the charts.
That's why I told her 1 through 9. So 3 over 8 plus 5 over 4. So now what are you going to do? You've got Devin right there to help you out if you need some help.
So 5/4 is an improper fraction. So we would equal this into 1 1/4.
So by turning this into a mixed number, we're essentially saying that this is the same as 3/8 plus, and I'm going to go ahead and decompose this 1 1/4. So this is the same as 3/8 plus 1 plus 1/4, right?
Yep.
So is there anything we can maybe set aside while we work with the rest of this here? Or is there, what would be your next step here? 'Cause I'm curious what your thoughts are.
Our next step would probably be to add these 2 together.
So you want to add the 2 fractions together?
Yes.
Could we take this 1 and just kind of move that out to the side here for a moment? Because we'll add that back at the end,
Okay.
right? So let's take our 1 here, and I'm going to keep you over here, pal. You stay with me, all right?
Okay.
Now we can focus on our fractions.
Okay.
We're adding 3/8 plus 1/4. But we have a bit of a challenge here, right?
Yep.
What do you think is the biggest challenge we face? I know you mentioned that you could add the numerators last time since the denominators were the same. But we don't have that here. What would we need to have happen before we can add these together?
Divide
Well,
or subtract?
we can't add them yet because we essentially have 2 different units, right? We have 3/8 and we have 1/4. We can't add 1/8 and 1/4 because they're 2 different units. So maybe we can find an equivalent where the 2 fractions do have the same denominator. So which one do you think you can move to a different denominator? The 1/4 or the 3/8?
The 1/4.
Okay, so let's model what this could look like here. let's say I fill in a square, and is there a part of the red there? Yeah. 1/4 of it is shaded. How could I turn this into another fraction where the same area is shaded? What could I do with this square?
I can
Well, instead of splitting this into 4 parts, could we split it into a different number of parts, let's say? Okay?
Yeah.
How would we do that?
We put more lines in it.
Yeah, let's put some more lines there. I'm going to go ahead and throw 2 lines in there. Ready?
Okay.
And then Now, how many pieces do we have?
We have 8.
8. We have 8 pieces. Out of those 8 pieces, how many are shaded in?
2.
2. So, how would I write the fraction of the area that is filled in? So I have 8 pieces.
2 8.
2 8s. So 2 8s is equivalent to 1/4. Now, I have 3 8s plus 2 8s. Can I add these together now?
Yes.
Let's do it. Go ahead. Adding those together. 3 8s and 2 8s. 5 8s. Now, there's something we have to bring back in.
The 1.
The 1. You come back over here. We have 1. We have 5 8s. It's all back together here. So, 3 8s plus 5/4 equals 1 and 5 8s.
So nicely done, and we've got about 30 seconds left.
Oh.
So that is a mixed number. I would like you to turn that mixed number into an improper fraction.
So she did 13 eighths very quickly. Could you describe how you were able to do that?
5 plus 8 would equal 13. And only 8 can go into 13 at one time. So.
And I would also add that this 1 is equivalent to 8 eighths.
Mm-hmm.
Now we can add those together because they have the same common denominator.
Yes.
So I think that was interesting that you saw it one way, ended up getting the true improper fraction, but it's this for this reason, because we're taking that 1 and converting it to a common denominator when we add it together. 13 eighths.
There you go. Nice work. Well done on that, Claire. 636-4357 is the phone number. We do have phone tutors available until 5:30 this afternoon. And quickly, just on a side note, we do have 2 schools in San Luis Obispo County battling for top spot between their schools, and that contest is going to continue through early December. Right now, we have one more opportunity. We'll head out to the Jet Center with Scott and Ryan.
Hey, thanks, Mike. We're back here at the Bakersfield Jet Center. Beautiful October day. And we told you when we left last time that we were going to talk about something that I'm really curious about. So, Ryan, if you can give us a little tutorial. The first aircraft that we looked at had a propeller. The second one was a jet. Why does this plane fly? Tell us a little bit about the propeller part.
So the propeller is really just an airfoil or a wing that's turned on its side and we spin it around. So if you were to look at the cross section of this propeller, you'll see that the top half is curved just like a wing and the back half is straight. So we use the same Bernoulli's principle to create lift, except we've turned it and now the lift is this way and we call it thrust.
Okay.
And in addition, the air coming off the back of this is being accelerated over the top, like we said before, and it's accelerated backwards. So when we take air and accelerate it, we know that for every action, there's an equal and opposite reaction.
Right.
So if we accelerate it this way, we get thrust that way.
So air goes this way and the plane goes forward.
Right.
Gotcha.
So when we spin this, we get air that's, as the prop's moving, we get air that's being accelerated backwards. So if we remember that force equals mass times acceleration. So in this case, the mass is the air,
right,
and we're accelerating it that way, so the force is this way.
Okay.
So that's how we get thrust. Now that works great as long as there's plenty of mass.
Okay.
So this is a big, if you take the propeller that's spinning this way, this disc that it spins through, it can take this much air and accelerate it. So it's a lot of mass, and it accelerates it a little bit so we can get a force.
Gotcha.
So
And
we
if
have-
you have one propeller on the front, it's going to accelerate some air. You have two propellers like this one does, one on each wing, you're going to accelerate more air.
Yeah.
And then at some point we're going to reach a maximum, and you can only accelerate air so quickly, right? So we like to go faster.
So we have those two, mass and acceleration, to play with,
right.
to get the equal force.
Sure.
Well, this takes a lot of mass and accelerates it a little. But as you go up in altitude, the air gets thinner and thinner and thinner.
Right.
So this jet over here can go up to 45,000 feet.
All right.
So what it does, there's no air up there.
Yeah.
The mass is gone.
Right.
So what it does is it takes a little bit of air, and at first it squeezes it with compressors. Those are what you're seeing mostly when you look down it. So we have we call that an N1 fan, but then behind that we have compressors that are squeezing and compressing the air so that we have something to burn. We're taking a little bit of air, then we light it on fire, and it accelerates out the back. So in this case, we're putting a lot of gas in,
right,
and we're taking a little bit of mass, but we're accelerating it a whole lot.
Okay.
So as you go up in altitude, there's not much mass to deal with. So the propeller, the higher you go, the less efficient it becomes.
Right.
So in a jet, you take that air that's there, which isn't much, you squeeze it, compress it, and then you light it on fire, and it accelerates like crazy out the back.
Right.
And that's why a jet is much more efficient as you go up in altitude. And the advantage to go higher in altitude is that there's less air, so it's difficult on the engine, but there's also less drag, so the airplane goes faster. The higher we go, the less drag, and the faster an airplane can go for the same amount of thrust.
Right. Wow. So we have a propeller airplane and we have a jet airplane. And most of the commercial airlines we see are jet airplanes.
Right.
How many actual engines does this aircraft have? Has two?
This has two,
Okay.
one just like it on either side.
Right. And then bigger airplanes have more than two engines, or are they mostly two?
Most airplanes now have just two engines.
Okay,
Yeah,
gotcha.
the engines are getting more powerful and more reliable, so
Right.
the days of 4-engine airplanes may be behind us.
Okay. And just a little bit real quick about the fuel. Tell us a little bit about the fuel, the difference obviously between what I put in my car and what we put here in this plane. It's got to burn differently. It's got to burn at a different temperature. It's got to burn at a higher altitude, obviously.
Yeah, so there's a lot of things that we have to be careful of. We have a lot of filters as
Okay.
it goes through the system.
Right.
We also heat the fuel in an airplane like this because at 45,000 feet, the air is about 65 degrees below 0 Celsius.
Wow.
So it's very cold. We can't have any ice in the fuel system. So we
makes
have
sense.
filters, we have ways, and then we heat it using actually hot engine oil. We use
okay.
it like a radiator, and we heat the fuel so that it doesn't freeze before it goes into the engine. All things that we have to think about from an
Right.
engineering perspective.
Right, and so there's all kinds of checks and balances here. If one system goes down, you got to be able to compensate another way, and certainly we wouldn't want that to happen, but if it does, you got to have a backup plan.
Right, and
Right.
in a lot of the systems in airplanes, we have two engines. We have backup electronic systems.
Yeah.
We have emergency extension. Like if we go to put the landing gear down and the hydraulics don't work,
Right.
we have a bottle in the airplane that blows it down.
Right.
So we have just different ways to do that.
Wow, that's so cool. Man, we're so grateful for the time you spent with us today. I know I learned a lot, and a lot of people, a lot of viewers got to learn a lot as well. We want to give you this wonderful Do the Math tile that maybe you can add to the inside of your office there. Really appreciate your time. Thanks so much for sharing some things about aviation. If you had real quick, if you had to tell a student, what's the one subject they need to master in order to be a pilot?
Well, math is obviously very, very important.
That's the
to
right
be a
answer.
pilot. Math, physics, aerodynamics, all of that, but it all comes down to math.
Gotcha.
And they all center around that. It's
Wonderful. Thanks again for your time. Mike, back to you in the studio.
Until we meet again, continue to do the math.
Major support for Do the Math has been provided by Chevron, the Kern County Superintendent of Schools, Edison International, California Resources Corporation, Kern Schools Federal Credit Union, Panama Buena Vista Union School District, Bakersfield City School District, and the Kern High School District, with additional production assistance provided by these supporters of education in Kern County and throughout the state of California.